Today we're going to answer an FRQ from 2004, and we're going to start with problem number 1. And in problem number 1, we are presented two additives that will help on the increase in gasoline mileage in cars. So there are two additives, additive A and additive B, and we're going to compare them using the information that we have on problem number 1. And in problem number 1, we are asked to show the graphical display for the differences between the two additives. So in this particular problem, we're going to be constructing a box and whisker plots, since we have the Q1, Q3 median, and we also have the maximum and the minimum values of the differences between additive A and additive B. So let's go ahead and start graphing additive A for our first box plot using the grid that is provided to us. So minimum is at -10, and maximum here is at +9. So -10 is somewhere here. Q1 is at 1, so somewhere about here. Q3 is the median, which is somewhere around here. Median is at 3, and Q3 is at 4, so somewhere here. And the maximum is at 9, and 9 is somewhere here. So if we construct our box plot will show this particular plot, and this will be additive A. And for additive B, we're going to start with -5. So this is -5. Q1 is at -2, somewhere here. Median is at 1, so somewhere here. Q3 is at 25, so it's somewhere here. And the maximum is at 40. So this will be our box plot for additive So to check if there are outliers, we're going to be using the 1.5 IQR rule. So at this graph, we're not going to be able to spot it, but by verifying it, by finding the IQR and verifying it to the left and to the right of the curve, we'll be able to see whether these or some of these are an outlier in our distribution. So let's start with additive A. For additive A, IQR is Q3 minus Q1, and for additive A, we know that Q3 is 4 minus 1, which is equal to 3. So this is our IQR for A. And for B, its IQR is Q3 minus Q1, and Q3 is 25 minus -2, which gives us 27. And this is IQR for B. Now to check for any outliers for the first group, let's visualize our box plot. This is our Q1 for A and Q3 for A. So Q1 is at 1 and Q3 is at 4. So the goal is to check whether all these will be away from the left of the curve and all these are going to be at the right of the curve using the 1.5 IQR rule. So for the lower limit, so we have 1.5 times IQR and 1.5 IQR of 3 is equal to 4.5. So if we're going to check all the outliers to the left of the tail, all we need to do is to subtract Q1 from 4.5 to check for any outliers to the left. So we'll have Q1 minus 4.5, and Q1 minus 4.5 will give us a value of 1 minus 4.5 equal to negative 3.5, which means any number to the left of negative 3.5 I considered outliers. And in this case, negative 2 is in, but negative 8 and negative 10 is outside our 1.5 IQR rule. So for lower limit, the outliers will be negative 10 and negative 8 because it's outside our range values for the lower limit. And for the upper limit, we'll have 1.5 times IQR again, and it's going to be equal to 4.5. And this time we're going to add Q3 plus 4.5. So anything that is outside Q3 plus 4.5 will be considered an outlier. And our Q3 is 4 plus 4.5 is equal to 8.5. So therefore, any number that is higher than 8.5 is considered an outlier. And in this case, 5 and 7 is in, but 9 is considered an outlier because it's outside 8.5. So outlier would be 9. So for additive A, our outliers will be negative 10, negative 8, and 9. So we have 3 outliers for additive A. And for additive B, we're going to use the same procedure. So Q1, Q3, Q1 is negative 2, Q3 is 25. So to the left or lower, we'll have the 1.5 IQR rule and 1.5 times IQR, and our IQR from B was 27. So 1.5 times 27 is 40.5. So anything that is lower than the boundary will be our IQR. So we'll have Q1 minus 40.5, and Q1 is at negative 2 minus 40.5. So we have negative 42.5. And in this case, our lowest value is negative 5, which is still inside our range of values for the lower limit. So for the lower outlier, there's none. And for the upper outlier, 1.5 times 27, which is equal to 40.5. Q3 plus 40.5 is going to give us 65.5. And from here, no values is greater than 65.5. So for the upper, there's also none. So in this case, we only have 3 sets of outliers, and we found it in additive A. And that's how we work out our problem for problem letter A. Now for problem letter B, we are asked to find the effectivity of the gasoline additive based on the graph. And for the first comparison, we're going to find out which additive between A and B will we recommend if our goal is to increase gas mileage in the highest proportion of cars. And these are the proportions of cars, or our box plot shows the data set of the cars who or which used additive A and additive B. And in this case, we know that in our box plot, the tail is 25% of the proportion of the cars with average mileage of this much, and this is another 25%. The other 25% is over here, and the lower tail is the last quarter of our percentages of cars that used additive A. And in this case, if we're going to be focusing on the increase in gas mileage, we would say that since additive A has about 75% of the proportion wherein there is an increase of gas mileage, because 75% of them, or about 75% of the proportion of cars, are above zero in their differences between the use of the additive A from before the test and then after using the additive test. So a positive value means higher mileage. So in this case, we would choose A instead of B, because you will notice at B, more than 25%, because this is 25%, and slightly above 25% of cars gives you negative differences, which means there's no increase in gas mileage in additive B when they use it for this group of cars. So for the first interpretation, we would use additive A because there are more than 25% of them who had an increase of gas mileage after using additive A as opposed to additive B. So let's go ahead and write out our answer for problem letter B. And this is how we're going to justify our answer for the comparison of additive A and additive B in terms of increase in gas mileage. Now for question letter B, we are supposed to compare it and recommend which additive will have the highest mean increase in gas mileage between additive A and additive B. Now for this particular problem, we're going to show the relationship between the mean and the median. So if we have a distribution that is slightly symmetrical, we know that the mean and the median are just approximately the same. But if the mean and if our distribution is skewed, the mean and the median will have slightly big difference between its value. So between additive A and additive B, and if we're looking for an increase in mean mileage for additive A, so let's inspect this one. This one is slightly symmetrical, or not rightly skewed as compared to the distribution of letter B. And we know that if we construct our distribution, the median is always close to the peak of our distribution, and in this case, the mean will be pulled towards the right of the curve. And that means the mean increase is more using additive B as opposed to additive A, because if we are going to sketch the skewness of the distribution, we are seeing that this one, the mean is being pulled towards the left or to the negative mean difference, as opposed to additive B, wherein the mean is pulled towards the positive mean difference. So in this case, if we're going to recommend an additive for the highest mean increase, we would recommend additive B. So let's go ahead and write out our answer for letter B. And this is our interpretation for why we chose additive B as opposed to additive A when it comes to increase in mean mileage.